this, I think, has a very good purpose, which is to cure important diseases, and ultimately to help secure humanity's future as a civilization relative to AI. The threads are very tiny, and there's a lot of them, and they're very carefully placed. And the operation on a per-chip basis, it involves just a 2 millimeter incision, which is dilated to 8 millimeters, and then the chip is placed through that, and then it goes back to being 2 millimeters, and you can basically glue it shut. You don't even need a stitch. So, and then the interface to the chip is wireless. So you have no wires poking out of your head. Very, very important. So it's basically Bluetooths to your phone. Because we'll have to watch the App Store updates for that one. Make sure we don't have a driver issue. That is not even a big finger. That is a small finger. So these threads are just like I said, way smaller than hair. This I think has tremendous potential, and we hope to have this aspirationally in a human patient before the end of next year. So this is not far.
Really hammered this in, but these things are very, very small. They're not. You can't manipulate these. This is one photo. This is not two photos joined together, and you really can't manipulate these with your hand. That part at the top is.
So there's very tiny threads that are about a tenth, roughly, of the cross-sectional area of a human hair. So they're extremely tiny threads. In fact, the threads that we have, like I said, even in version 1, are about the same size as a neuron. So if you're going to go stick something in your brain, you want it to not be giant, you want it to be tiny, and to be approximately on par with the things that are already there, the neurons. So this is about the size of a neuron, each thread. And then you really need this to be done with a robot. It's sort of quite a complex device, but it all comes down to a very tiny. So you can get a sense for the robot doing the electrode insertion. That's a very zoomed-in view. So they're all very, very tiny, and the robot is very selectively applying them very delicately, and then.
Quick and precise placement of threads into the cortex, and then we fill that hole in the skull with the sensor, allowing the scalp to be closed up over it. Behind the ear, we'll make a small incision to insert the coil. We will tunnel tiny wires under the scalp to connect the sensors to the coil. That's the process.
But the key is like this is something that, and I've said a lot about AI over the years, but I think even in a benign AI scenario, we will be left behind. And so, and hopefully it is a benign scenario, but I think with a high bandwidth brain-machine interface, I think we can actually go along for the ride. And we can effectively have the option of merging with AI. I think this is extremely important.